So I'll get right into it. I'm going to be presenting to you today our latest generation of the Hive, which is a big data management and storage solution for microscopy. So for those who have not heard about Bruker Luxendo or Luxendo as a company, we are we are in Heidelberg, Germany, distributing worldwide. We are quite a diverse team of physicists, biologists, engineers, and most of all, also IT experts. We produce and manufacture, distribute, and develop not only light sheet microscopes here in Heidelberg, but also screening microscopes. And with those kind of systems, there's always the question of big data. So we have the Hive as a big data storage and processing platform available. With the Hive, we have already 150 plus customers worldwide, ranging really from Northern America, Central, Northern Europe, Southern Europe, all the way over to Asia, to China, Japan, as well as Australia. Those units are basically either situated in individual research groups, which are basically just the storage solution for single individuals, or we are also the backbone for imaging facilities that use the Hive to make data accessible. Or in most extreme cases, we are used, or the Hive is used as really the backbone to a full research institution, giving like or formulating the entire IT infrastructure. And as I said, we are mainly microscopists here in Heidelberg. We work with light sheet microscopes, as you can see here in the background. We have a couple of them in our showroom. But so we know really the problem with the large amount of data these kind of microscopes produce during time-lapse imaging, during screening, especially for large data sets. And those like raw data sets can range really from a couple of gigabytes per day with a standard wide field epifluorescent microscope up to like high content screening or light sheet microscope that on average and in medium can produce up to several terabytes per day. And this kind of data is then first stored on these acquisition PCs that usually come with the microscopes. But those storages are limited. And then the question is what to do with those, with these raw data sets afterwards. But we don't only want to limit ourselves to imaging data, also other research fields such as spatial biology, single cell sequencing, mass spectrometry, or a whole genome sequencing can generate gigabytes and gigabytes of data every single day in every single run, producing a large amount of data that need to be handled and most of all processed and analyzed. And how to do, what to do about that, this is the main topic of today's talk, how to handle this. And I think in this sort of diagram, a lot of you will see yourself using either outdated network transfer speeds of just a single gigabit network speed that can then only transfer a couple of 100 megabytes per second, taking ages to move data from the acquisition PC to a workstation where you can then do the analysis, or even worse, than to your laptop. Users often come to a facility with large external hard drives that are size limited, and then they come with a full stack to copy basically a full data set onto a analysis PC. Or you might have a cloud storage and processing solution where the upload speed can be extremely slow. Often there is this safety requirements in place so that you cannot plug in hard drives. So how to move the data copying and storing is always extremely challenging, slow. It involves multiple steps. And sometimes you lose track of where the data is. So you don't know where you have left this or that data set a year later. And with all these key pain points in mind, the Hive was dedicated and developed to really reduce the number of steps that the data has to take until it's processed and analyzed, and to increase the efficiency. And for this, the concept of the Hive really plays nicely into like a research imaging facility, where you have the multitude of acquisition microscopes with their dedicated processing PC that are then filled up to the brim. And then from there, basically, you want to copy the data to a centralized storage. And this is where the Hive comes into place. We can have up to 100 gigabit of data streaming from one of these acquisition PCs to the Hive. So giving you really a fair bit amount of around 12 and a half gigabytes per second maximum capacity network speed to move the data really off this acquisition PC onto the Hive. And on the Hive, because it's such a centralized storage unit, then all the data from the entire facility, from the research group, or from the entire institution is then stored. You then have the possibility to use VPN and remote desktop to sort of remote into the Hive and work on your data. So you have a remote desktop with a very slow internet connection that can give you even the full access to the data. And this can be done really from anywhere in the world, basically from the home office, from a conference where you have a really crappy network speed because so many people are using a small router. Even with the fast internet on airplanes, you could even download on the way to your conference, make screenshots or download individual files that you want to then process or visualize to your colleagues, or from a remote island holiday whatsoever, because your collaboration partner wanted to get this last image. So you can have really a good access from basically anywhere in the world on the centralized storage, and where your data then is really pushed together. In terms of where it sits in the range of a standard control PC to the cloud computing, the Hive really finds a really nice niche in between those, with a local access, but you have a remote access from, as I said, basically anywhere in the world. The administration is done through so self-administered. You have one administrator or multiple that then take care of really moderating the projects, administering the users, but this is all supported through our software. You can scale up the Hive with the different modules, which I come to in a minute, and because the way it's set up with Windows Server 2025, it's multi-user capable. So you can have a lot of users locally as well as external to access different projects. In terms of performance, it's highly upgradable, and usually we design the Hive for the customer to fit on one side to the budget, but also to the standard requirements. So it's highly customizable. And you don't have these problems with IT support not being reachable for several days on cloud computing, or the lack of performance on a small computer. In terms of the modularity that I have already mentioned, there we go. There are different modules that can be combined to produce this entirety of what we call a Hive. So we have the Hive core, which is basically the centralized high performance data processing and primary storage solution. The second one would then be the Hive data, which allows high accessibility to large data sets, up to 1.5 petabytes of data storage available that can be configured in RAID 6, so you have redundancy and data security. We have the HiveNet, which is sort of the data hub where you connect all the different instruments, all the different microscopes or other entities, connect them together to make the Hive really the centralized data storage. We have the Hive GPU that can be equipped with multiple high performance GPUs that are then used for power computing and are especially useful in AI processing. And an additional module, the Hive satellite, is basically a external workstation that can be used for encapsulating processes or making defined resources only available to a single user. We then also developed the Hive Backup, which is basically just an offsite data storage unit. So let's go into the individual key units of the Hive. So the center, as I already said, is the Hive core. This is where the data processing takes place. And we have a primary storage that is based on NVMe SSD RAID system, meaning the read-write speed is incredibly high. And this is where you store the data after it comes from the microscope first to do fast processing of the data. We are using Windows Server 2025 as operating system. That gives a lot of nice tools for multi-user administration and project definition. And it gives really, via this remote desktop, accessibility from anywhere in the world. The software is now really centralized in one position, in one location in the Hive. And it's not like you have a workstation that only has an Imaris license and one that only has a Zen license, but you have everything in one place. So the support is really easy. Booking is really easy. We optimized our Hive core to be silent and energy sufficient. And if you look behind me, basically, we have a setup of the Hive, which is currently running. And I still can give a nice webinar here, but I'll come to this in a minute. Yeah, administration, user-defined, and data access is done through our customized software that then lets you define who's a user, who's an administrator, and who has access to the different data sets or projects. We can establish virtual machines based on Windows or Linux on the Hive core. That allows, again, this encapsulated processing for especially for some users that want to do high performance processing, and that would otherwise sort of detain or dedicate too much of the resources of the Hive to a single user, a single processing pipeline, so to keep everyone else also happy. And again, VPN and remote desktop allows a remote access from anywhere in the world. We have worked and we are continuously working with all the major companies, as well as we try open source software on the Hive. And we have a good relation really with all these manufacturers of the software to make the data as performant on the Hive as possible. This is our dedicated Acquifer dashboard that can be used by the administrator to define, for example, the users, who's a administrator, add users, and then as soon as you add a user, they get an email with the VPN access and a remote desktop configuration, so they can basically start off working right away. It takes only a couple of minutes to set this up. Also, in terms of data protection, data management, we have this sort of possibility here to define projects that then individual users from the Hive, from the entire group, then have access to. This is where we come to the next generation part of my presentation. So beginning of this year, end of last year, we have completely redesigned the Hive core really from the ground up, looking at every single component, analyzing how we can increase performance. And there we decided for the HIVE Pro to go for the Ryzen AMD Threadripper Pro series, which in all benchmark tests is sort of really the highest performing single core, single CPU, CPU. And it can be ramped up or configured up to 96 cores and really topping every CPU performance chart. They can have up to 5.4 gigahertz boost clock speed, so they're really, really fast processing on a single core, but also multi-core processors, software like Imaris, Rives, and so on and so forth, can make use of these large amounts of core while still having multiple users doing multiple processes. In terms of the GPUs, we decided on the latest generation of NVIDIA RTX series, so the Blackwell series. And here you can have up to 96 gigabytes of VRAM, which is extremely important, especially for the for AI applications, to have this large amount of VRAM. The primary storage, we now decided going away from standard SSDs and now selecting really NVMe SSDs. And if you look at the performance figures in the next slides, you'll see really what is the difference between just a simple HDD and SSD and the fast NVMe drives. And here we not only have the operating system on a mirrored NVMe SSD, but also our primary storage, really inside the core, fast access to a primary storage where you move the data first, have it stored while it's being processed, and then it's moved off from the Hive core to the Hive data. And here you can either have a RAID 0 configuration or a RAID 1 configuration that is more for safety, while RAID 0 gives you the largest amount of the space available. And here we often work with the users to configure this. And the benefit really of having a RAID 1 mirrored setup, and why we also have the operating system on two individual drives, is that all of those are hot swappable. So if the system detects that one of the hard drive fails, you can just take a new hard drive, plug it in, and it will rewrite itself automatically without any downtime of the Hive, non-visible to any of your users. We now then did a benchmarking, really comparing our former flagship Hive, which was the HIVE XXL, so the largest one with the most amount of cores and GPU and CPU, which had a total of 128 CPU cores, a terabyte of RAM, and the largest available RTX graphics card, the 6080A or ADA, I don't know how to pronounce it still. And this was basically our beast for any workshop, for any presentation, where we had multiple users access. And it was really high performance flagship Hive that we use. Now we compare this one to, let's say, a medium range HIVE Pro XL, which has half the number of cores, faster clock speed, of course, but half the number, half the size of RAM. The same size of graphic card, just the latest generation, paired with our SSDs. So this was basically the benchmark test that we did, comparing our old flagship to a medium-sized Hive in our latest generation. And if we look at CPU performance scores using Cinebench on a single core or multi-core reference here, we see that really on the multi-core tests, we see a 20% increase with half the number of cores. So because we used only 64 cores instead of 128, even with those lower number of cores, we had a 20% increase. So that was quite significant. If you then look at the power versus processing performance on this newer Hive, talking now about energy efficiency, the consumption went really down by quite a large margin. So the cost of ownership, and with that also the cooling requirements of the newest generation of Hive has sort of halved. Now comes really the party piece of, in my opinion, to this newest generation of the Hive. And this is why I said switching from HDDs to SSDs to the NVMEs makes a huge difference. If you look at sequential access using Crystal Disk Mark, again, a benchmark for data accessibility, we see a quite drastic increase in the read speed. But usually data is not sequentially written or read. And with the Hive, with multiple users, they want to have really random access, one wanting to look at the lychee data, the other at the epifluorescence data, the third one wants to write something to like a large project to the SSD from a microscope. So it's more a random access. And here, really, these NVMe drives are outperforming anything. And we see an 18-fold improvements in the performance. And IOPS is really input-output operations per second. So larger is better with this Hive. If we then look at real life, real world performance using our own Luxendo processor, where we just fused a 3x4 tiling via stitching, a total size of 42 gigabytes. On the old Hive, this took around 60 minutes with deconvolution and a few different other processing, really moving this data together into one output data set. And we see a 2.5-fold increase of processing. So really combining all these different hardware improvements that we've done to the Hive, from the SSDs to the CPU to the GPU, has really shown a real life high increased performance. Something that some people might more relate to is a cell post processing on a fused data set. And here we saw a 2-fold increase of the processing, going really from 21 minutes on the old Hive to 10 minutes on the new. Often we're asked if we can do Linux on the Hive, and the simple answer is yes, you can do Linux. You can either integrate those as virtual machines using Hyper-V, or we are currently also working on running the entire Hive on a Linux operating system. So if you're interested in that, just let us know, talk to us. And of course, Docker is also something that is possible. I'm reading a question here. We have a Hive system in our room. Okay, so the question here is basically Zen, using Zen on the Hive. This is more general question, I guess. Maybe I'll come to this after the presentation, because it sort of goes into this multi-user setup. Let me come to this. Okay, in terms of environmental consideration, that is often something that we're asked. So what's like the power consumption for the Hive? So we did a real live measurement with the Hive on idle using 200 watts, and then at full capacity, doing benchmark tests on the CPU and GPU, we went up to 870 watts. So that is sort of the equivalent of 4 more people in the room. And in terms of noise, the machine, as you can see, is really running here in an office space where I can talk to you, no problem. And we did a real life measurement on this with the GPU and CPU doing benchmark testing, and the noise level 50 centimeters from the Hive was below 50 decibel. So on an average office space, your noise level is somewhere between 45 and 50 decibels. So it is a really quiet and really well optimized setup that can be run and positioned anywhere in a facility. And often the cameras from our microscopes are much louder than our HIVE processing unit here with the HIVE. Okay, there we go. Data storage. I'm always talking here about large data sets, so multiple hundreds of terabytes of data that need to be stored. So in the core, we have this primary storage, and then we have the module, which is called the HIVE data. The HIVE data is a HDD RAID 6 array that's running really a server-graded technology, and it has a high-speed connection to the core with up to 3 gigabytes per second read-write speed, copying of the data from the core to the data module. And it can be ramped up and configured up to a maximum of 1.5 petabytes. And the upgrade is as simple as just putting another box on top of your tower, adding, doubling, quadrupling the amount of available data storage. And really, the upgrade is extremely simple and straightforward. Another module I want to talk about is our HiveNet module. And here we also upgraded the capability, going from a 10 gigabit network connection to now a 25/100 gigabit setup, where we connect really the HIVE to the switch with a 100 gigabit connection, and then all the other microscopes can be connected via 25 gigabit connection. And a single microscope that is usually the powerhouse of the facility being connected via a 100 gigabit connection. So you have all the bandwidth that is needed to copy the data from really large amounts all around the institute, large amount of research instruments, microscopes, sequencer, whatever, and move the data through the net module to the core. We also equip this with a UPS. So even if there is a power outage in the institute, your data will not be voided or damaged, because the UPS is basically like a battery, uninterrupted power supply that then detects this power outage, and after a couple of minutes safely shuts off the HIVE core without any data loss. And this is where the IT people in our company come into place. We like talking to local IT to integrate really the HIVE in total via the net into the local infrastructure. So that's something that you as a user don't need to do, but this is part of our agreement. When you purchase a HIVE, we are working closely with everybody who needs to be involved in terms of security, data security, in terms of network administration, in terms of whatever administration, to get really this HIVE into your facility, integrated in such a way that everyone, especially the IT people, are happy, and you as a user can just straight up go ahead and start working on this. We also do another stress test, and in my opinion, this is more useful than just using Cinebench or some GPU benchmark tests. And these are really our workshops. And here I would like to highlight last year's trends in microscopy, where we had a total of 3 hives in, I don't know if you have been to Tim, but it's a multiple buildings across a full campus. And all these 3 hives, 2 of them we brought there, were then in the end linked via 2 kilometers of cabling, generating a 10 gigabit network across the campus, so that during different workshops, up to 80 users simultaneously could access the data. We collected up to 150 terabytes of raw data from 20 different microscopy systems all around the campus, and doing really processing using their individual software. And this is really the key point of the HIVE. It's multi-user, large data set. The last module I would like to talk about is our HIVE core. That is an extension to the HIVE core. It's our HIVE GPU module. And here you can expand with up to 8 dual slot GPUs in this module, giving you really significant processing capability, especially when focusing on deconvolution using, for example, Huygens, or AI-focused scripting. Could be in Python, something, a script that you write yourself, or dedicated software, then Arrives, Imaris for visualization and AI-based data processing. And here we see a continuous drive really towards these GPU-based processing algorithms around the different software, open and commercial. And really this, with this GPU module, you can then do a high performance parallelization. Talking about AI processing, you could also basically establish your own private AI chatbot on the Hive using either a open source large language model that does not require any internet access and is really run by you based on something like Claude Code or OpenClaw. And with our latest generation of Blackwell GPUs, you can even use the largest language models like DeepSeek, Minimax, GPT, SS, and so on and so forth. So you're really not limited in the capabilities of the Hive. With the Hive Pro, we actually have a lineup, as I said, a medium-sized as a benchmark here. We can basically do anything from 24 cores to 96 on the Hive Pro module, all having the same clock speed. And the RAM can be really configured up to 1 terabyte of RAM, depending on the budget, because RAM prices have been increasingly have increased drastically in the past months. We then can also look at the GPU range of what is really applicable to your setup, what is your requirements, and then we can spec the GPUs to those accordingly. And as I said, the primary storage can be either small or up to 60 terabytes of fast NVMe storage. But sometimes this Hive Pro is just not enough. It just doesn't cut it, especially since we're looking into being the backbone for entire research institution, being really the centralized storage for a lot of users. And here we dedicated ourselves to generate and produce the most powerful, the largest Hive that we could think of, still maintaining the same form factor and properties as I have discussed before. And here we suggest that larger facilities or institutes where we really are the dedicated infrastructure for data storage and processing with more than, let's say, 20 users on a day-to-day basis doing high demanding processing in multiple ways in high parallelization. And this is where really the HIVE Epic configuration comes into play. Here we use the 5th generation of the AMD Epic server CPUs. And because we have a dual CPU setup, you can have up to 192 cores with twice the memory available, so up to 2 terabytes. And our NVMe SSDs are not limited to 2 times 30 terabytes, but can be up to 6 times 30 terabytes, so 180 terabytes of extremely fast 20 gigabytes per second read and write speed. This is then our lineup going really from the smallest one, 96 cores, up to 192 cores. That is really a powerhouse that is contributing really as a centralized storage for larger institutions. In comparison, the HIVE Pro is, sorry, we upgraded our old Hive setup, doubling its performance over the previous generation, focusing quite a lot on AI-driven processing and using really the fastest CPUs currently on the market. With the HIVE Epic, we are really focusing on extremely demanding application with larger groups wanting to access large amounts of data extremely in a parallelized fashion. And with dual CPU and 2 terabytes of RAM, we really max out the capabilities of a centralized storage. In general, in summary, and this brings me to my last 2 slides, the Hive is a highly modular setup with data module available for a large data storage up to 1.5 petabytes, the core being the centralized processing unit ranging from, let's say, just a high performance workstation with multi-user access all the way to a really high performance server for large amounts of data processing in parallel. The net is sort of the connection hub that integrates into your local network, into the local infrastructure. And here we are available to aid you in the implementation using our knowledge and our software. The GPU is really dedicated to accelerating power computing, visualization, deconvolution, AI workflows using multiple GPUs with the Hive satellite that I not talked about and the Hive backup as different entities that can be then added at a later stage. And in really my last slide, in summary, I have presented to you the Hive as really a turnkey solution for data handling and processing. It's a tested and proven product with 150 customers worldwide already, where we have fully integrated the Hive into the existing infrastructure, aiding you in just starting to process your data the day this is set up. It can be configured to your requirements, having a large range of versatility in terms of the hardware specification, really being dedicated to your workflow, what you really require, and to your budget. And if the budget then grows and the demand grows, you can add on your modular basis different components over time. And because we have this really great support on the IT side, as well as the software that is used for administration purposes, there's really no special IT knowledge required. With the VPN and remote desktop access, you can have a worldwide accessibility by collaboration partners and yourself from home, from the workshop, from the conference, or if necessary, also from the holiday location. And because we are part of the Bruker family here at Luxendo Bruker or Bruker Luxendo, you have a really strong partner with worldwide contact and support. And with that, I would like to thank you all for your attention. I saw that there are now 2 questions about the Hive, and I'll come to those in a minute. But yeah, for this, thank you so much for everything. I will be with the Hive at ELMI. Look out for my workshop where I'll be basically presenting an entire workflow from light sheet acquisition to data transfer to data processing. Come to me, talk to me there. I'm looking forward to meet you in person. With that, thank you so much. Okay. You can just post your question in the chat if that's okay. I see already here a question about ZenLight multi-user accessibility. So it depends really on the Hive, on the license that you have acquired from Zen. That is the same for Imaris and so on and so forth. And if I understand the question correctly, the setup needs to be in such a way that you have a multi-user license. If that is talking about an open source availability, we would need to talk to Zeiss or Zen about this multi-user accessibility to the software, and maybe just repositioning really the software from the general accessibility folder to an individual folder, and be basically doing an installation per se. But that is sort of really good feedback if I read this correctly, and I'll handle this accordingly. The second question is, does the Hive have safety measurement in case of a discontinued network connection during the file transfer? Okay, I mean, the benefit of a discontinued connection is really you're copying the data. So on our light sheet microscopes, we sort of have an on-the-fly data transfer, but the data is still retained on the original acquisition PC. And then as soon as the data is basically copied, there is a confirmation, and then you can delete it on the acquisition PC. As soon as it's on the Hive, it's safe. It's really accessible and stored in the RAID setup. But if there's a problem during copying, you can just restart the copying process. Do you have admin tool to facilitate VM development with pre-configured resource allocation? Well, with the Hyper-V software, really setting up a virtual machine is something that can be done extremely fast and efficiently. I don't know if there is a defined preset, but since you want to allocate defined resources and adjust to those, it's really simple to set up these virtual machines through the available software. So tell me, just looking forward, which range of prices for the Hive system? For this, I would like to pass over to my colleague here, Felix, who's our sales representative for Northern Europe, and he will be able to answer these questions. So I can read on and look at the next one. Felix, you want to answer this?
Oh, hi. Yes, thank you. That's of course a range. So starting from around 80,000 euros to, depending on how large you want it, it can also come to around 200,000 euros, really depending on your needs. It's highly versatile and highly modular. And yeah, happy to get in touch to hear if you have any specific needs, and then we can configure something and tell you more about pricing.
Thank you, Felix. Okay, how do you manage resource allocation when multiple users are connecting at the same time to the Hive? That is actually a really, really interesting question. In general, we leave the resources, meaning GPUs, CPUs, read-write speed, as open as possible, so that everyone can make use of these resources, meaning everyone can have access to, if necessary, to the full GPU capabilities. Some softwares like Imaris, Huygens, are dedicating individual number of cores and GPUs to their software. And often this is also combined with a licensing model that they give. So each software does not take all the cores or the entire GPU in their own. If you then still have some requirements in terms of managing a single user because they're tending to use the entire resources of the Hive, because they have scripted something to parallelize on 192 cores, as well as all 4 GPUs that you might have installed. Then you would likely want to have a virtual machine set up for this individual user, dedicating really to their workflow a virtual machine, and with that, storage, core usage, and GPUs. And this is a nice tool that then we can show you how to set up and for the administrator, and then work with your users in combination. And this can be, especially for facilities, this can be a nice tool for billing. So it could also be potentially something that is quite beneficial. Last questions. How do we manage the transfer? Is it automated? Okay, that is really a great question, I have to say. Because what I just said is basically you acquire the data on the acquisition PC and they tend to fill up. So you want to copy the data automatically from the acquisition PC to the Hive. And this can be done in two ways. Luxendo does it in such a way that we have a script in place in our software integrated that basically on the fly copies data while the acquisition is still running. And I say copying, so there, even if there's a network outage or something like that, the data is not lost or somewhere lost in translation to the Hive, but basically as long as there is network speed available, it will start copying the data. Even if multiple people are reducing the bandwidth, which is in most extreme cases just a valid point, but mainly with the upgraded network, we are really on such a level that we're solid, even with multi-user setup. As soon as the bandwidth gets smaller, back to my point, there is a continuous flow of data. This might not be true for every software manufacturer or microscope manufacturer. Some have this in place, some have not. If you don't have this in place, there can be simple scripts that basically look at a folder on your computer, and then you define in target location, which is then on the Hive. And as soon as data is ready for copying on your acquisition PC, mainly when the time point is finished, the acquisition is finished, something like that, it moves automatically the data onto the Hive. So these are the two options that you have. And this is actually a quite interesting point, and I think it makes sense to integrate this more into our software, into the dashboard. CLU, the GPU acceleration plugin for Fiji. Okay. Troubles me for a long time. Okay. Thank you so much. That is great to hear that this is now working. So as you can see from this comment, we're continuously working together with all the manufacturer for commercialized software, size like Avivis, Huygens, whatever you can think of. But also we have a good connection during these workshops with these open source software developers, Fiji, and especially Fiji. And here we continuously like to help and aid and improve. So if you have a Hive, you have a support email address that is read by multiple people continuously 24/7. And usually you get a response quite fast, and if there's a technical issue or if there's a software issue. And we then try to work together with those manufacturers of the software or the open source community to aid those individual users. And because we have such a large user group with 150 plus worldwide, we have actually a good standing in this community to actually move stuff and get problems solved quickly.
Okay, thank you so much. There is one more question. I'm going to read this. Do you have some strategy to avoid overhead during transfers of thousands of files, or is that better handled in WinServer?
What do you mean with overhead? Like latency or?
Yes, latency.
Latency. Okay, so in this regard, I would want to consult with our IT people. From my side, I'm the application and product manager. In general terms, our latest generation really with the 25 gigabit network connection. We don't see any bottlenecks nowadays really on the transfer speed of the data, because microscopes tend to have something like up to maximum 4 gigabytes per second. If you have multiple of those running in synchronously, yes, you might want to might have some form of reduction in the transfer speed, but it's nothing that will be visible on a day-to-day basis.
Okay, yes, thank you so much. If there are no other questions, then I think we can stop here. We'll just stop the recording.